Hello, everyone. Thank you so much for attending this presentation. This is part of my PhD project. This is titled New Stratigraphic and Petrologic Observations of the Catastrophic 4,000 years ago sector collapse of Antuco, a basaltic volcano in the southern Andes of Chile. So, first of all, I will talk about sector collapses very briefly. Basaltic volcanism at the southern Andes. What is Antuco volcano on my last field work, and then I will talk about its debris avalanche deposits and post-collapse stratigraphy and insights from the plumbing system with future research. So just in general, I will say that sector collapses are very catastrophic events that occur in many volcanoes, and they transform the overall surrounding landscape and environment, but also they transform the volcano itself, because volcanoes change their composition and rapid behavior depending on the scale of the sector collapse, and naturally on the response of the magmatic plumbing system to the unloading force of the sector collapse. Not always, but it most of the time it happens like this. So they can also produce huge tsunamis, like in the case of an Krakatau in 2018, that was followed by also by a big enhanced eruption. So basalts are not very common in art settings, but primitive magmas are always generated by subduction, and it will depend mostly on tectonic settings to transport this mafic magma to the surface, and without too much fractional crystallization and evolution. So those systems are favored by transtension and transpression in most of the art settings, because it's an overall compressive environment. So most of the volcanoes in the world, independently of their composition, can have catastrophic sector collapses, and it will depend on a series of elements, internal and external forces, such as magma injection, hydrothermal alteration, glacial retreat, ferrovial erosion, and even the condition of the basement that can have some regional faults or can be soft and facilitating the spreading of the volcano. So the basaltic volcanoes in southern Andes are very common, are not very common, sorry, but they are controlled by transtension and transpression by a very long fault that is named Volcanic fault, about 1,200 kilometers long, and this melts at the end are favored by tectonic settings that are orientated northeast in trending faults. So most of the basaltic volcanoes have these northeast trending faults, and most of the northwest trending faults are related to more evolved magmas. So this is the case of Antuco volcano, and this volcano has another volcano, very old, next to it, and his name is Sierra Belluda, and both of them are orientated northeast. So in terms of Antuco stratovolcano, it is a volcano that has evolved in three different stages. The first one, 150,000 years ago, and it ends at about 17,000 years ago with a change from the acidic and basaltic andesite volcano to a basaltic system, purely basaltic system, and then it moves into another basaltic stage after the sector collapse about 4,000 years ago in the third stage of evolution. So this volcano has many historical eruptions, and those eruptions are mostly strombolian, and some of them maybe violent strombolian in style, and some even subplinian. So the eruptive record is comes from about 400 years ago. So just before the sector collapse, the Antuco volcano was purely basaltic, producing this lava flows with the Olvan pyroxene. And then we have the complete failure of the edifice, and we have here the map of the debris avalanche, which is about 5 cubic kilometers in debris, and then it's followed by alluvial deposits that are in yellow in this map, in this image. And the eruption was followed by dilute pyroclastic density currents and long lava flows, and then intense reworking of those materials, of all of those materials. So my last field work was related to mapping this debris avalanche deposit, and with a collection of more than 71 points between January and or in January and in December 2020. So the debris avalanche deposit has a characteristic hummocky surface, and it varies from 20 to 90 meters in thickness. So it gives a total volume of about 4.5 cubic kilometers, and there is a complete phase transformation along the deposit from terreba blocks to matrix phases with scarce organic matter included in the matrix. So most of the age constraints can be done by pulsars below and above the debris deposit. So this is a characteristic terreba block with the preserved internal stratigraphy before the sector collapse. And then we have this very typical geysophyte blocks, which are very interesting because they are in about 5% of presence inside the deposit, and they are pure basalts, aphanetic basalts with a lot of xenolates. And this can be maybe can be interpreted like some sort of juvenile material into the avalanche mixed phases, and then the transformation to matrix phases far away from the source, and some clastic dikes in the basal phases, which are fine grained, and some intrusions of pre-existing materials into the avalanche. So in terms of the stratigraphy, after the sector collapse, you will find a very interesting series of pyroclastic density currents and 2 lava flows, which have a particular composition that is giving some insights of mixing after the sector collapse. And on top, alluvium sequences that are related to lake outburst processes occurring after the blockage of the drainages as consequence of the avalanche. So proximal outcrops have also some records of temporary lakes formed in this area, and those sediments of the lake have some convolute structures that give some insights of earthquakes occurring during this process before the violent outburst of the lake. And far away from the source, there is a lot of unconsolidated sediments, basaltic ashes that have been transported from the volcano to the valleys and to the ocean, and they resemble this kind of alluvial sequences after the sector collapse. And to the eastern sections, we have the recognizance of a plinian deposit, a tetraphile deposit that can be related because it fits in age with the debris avalanche. So it can be related to the sector collapse, post-sector collapse eruptions. So in general terms, we are now collecting and studying the samples in terms of texture, vesicularity, and chemical composition, mineralogy, to establish all the pre and syneruptive conditions of the plumbing system just after the sector collapse, and how the system reacts to the loss of pressure. So in general, we are doing this work in three stages. The first one is the field work and the debris avalanche deposit. Then we have numerical modeling of the conditions of the reservoir, and we have this constraint with the petrologic information from the samples collected in this study. So this is my PhD project, and I will put some other volcanoes in this research, but this is my main target. Thank you so much.